I'm going to explain the climate of the breadbasket by using a variety of maps. And start with the Climate Zones World Map. This is from maps.arcgis.com. So what we have here is over here on the left, or sorry, the right, we have the legend, and we see this kind of this area right through here is the Great Plains, and then the Corn Belt right through here, the Great Lakes, Indiana, and all of that. We can see most of the Corn Belt is this humid continental. Humid continental, as the name implies, means humid. It's going to be some good amount of moisture, consistent amount of rainfall, enough humidity in the air that we're going to see a little bit more vegetation than the other areas of the breadbasket. Further, as the name implies, continental, we're going to see some fluctuations in the temperature. We're not going to be right there along a coastline, so we're going to have warm temperatures in the summer and cold temperatures in the winter. We go over to the western part of the breadbasket, here the Great Plains, we see this orange color which is associated with a steppe. And so this is kind of a change in the pattern. Here it's very linear, very horizontal, going left to right, or maybe some would say geography latitudinally, where here we're going up and down. So we can see along this line of longitude, we see this particular climate region, whereas the other ones kind of change based on different latitudes. And overwhelmingly what explains that is the role of the rain shadow effect in the Rocky Mountains just to the west of the Great Plains. And that's a steppe climate. So the steppe is kind of, as the name implies, kind of a step or a transition from drier areas to wetter areas, from deserts to forests. And so this is often associated with grasslands as well. We go up to Canada, we can see a very similar pattern. Humid continental changes then to more of a subarctic, and so what happens, a little bit more precipitation a little farther up here, but it's also colder. Good amount of precipitation, colder temperatures, hello evergreen trees, and so the vegetation type here is different than the grassland areas we'd find here, or maybe the forested land, the deciduous forest of the Corn Belt, which we'd find in Indiana. Let's go now to another map, and that's a climate map, and here it distinguishes this humid continental area into two different groups, and that two different groups is the hot summer and the mild summer. And this once again relates to latitude. And so these are areas that have really, really hot summers, where here are areas that have mild summers. And so they're both humid continental. They both have very large fluctuations in the temperature throughout the year. They're very temperate, very seasonal. But here in this particular area of the breadbasket, the Corn Belt, Indiana, Iowa, it can be very, 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 very hot in the summertime. And we know that quite well, especially if we've spent the last 10 summers in Indiana. Let's go to the next map once it loads, and this is average temperature from January 1st, 2016 to December 31st, and we can see different colors associated with warmer temperatures, cooler temperatures, and once again the latitudinal effects. Very much, we're not going to see the role of mountains too much here, and that makes sense. It's flat. I really try to emphasize that in the topographic section of this chapter by showcasing the very flat terrain. It's like a pancake, and so subsequently we're not going to see much change in the temperature based on changes in altitude, changes in ruggedness of the topography. It's very flat. We look at different extremes. That's one of the themes. I'm saying extreme for a reason, because we're going to see extreme weather events overwhelmingly in the breadbasket. Tornadoes, blizzards, but also extreme temperature differences. And so extreme maximum temperature here, you would think, well, wait a minute, Texas and way up here in North Dakota, Montana, they can actually have very similar warmest temperatures of the year? Yes. And this goes back to the idea of continentality. The deeper you are within the continent, the higher fluctuations you have in the temperature. And so in the summertime, it gets extremely hot the deeper you are within the continent. Down here in Texas, moderated a little bit more by the influences of a water body, the Gulf of Mexico. Here, it can be very, very, very hot in the summertime. That's because of the absence of clouds. So the sun comes scorching through the atmosphere and heats up the surface, but also it heats up the surface and has no way of an ocean or a water body cooling down or moderating the temperatures in that particular area. Subsequently, we're going to find cold temperatures, or coldest temperatures during the wintertime, because once again, land heats up real fast, but also cools down real fast. And so we're going to see extremes in temperatures, particularly there in the northern Great Plains. But we can see, once again, these kind of latitudinal effects, but once again, kind of also follows the coastline. Way down here is the Gulf of Mexico, but we see still a very similar pattern. Deeper within the continent, larger changes in the temperature. We can further showcase this by this weather.com, in which it shows average high temperatures and low temperatures for January, and I'm going to go throughout the year. But one of the things to note is the differences between, let's say, Texas and North Dakota in the wintertime. Large differences in the temperature, especially in the winter and the spring. We go to February. We also can see the isotherms, or these isolines, they kind of bend towards the equator. A very distinctive pattern here in the interior. Also, one of the things I want to note is the role of the moderating influences of the Gulf of Mexico, but also the Great Lakes. And so we're really going to see these huge changes in these lines here deeper within the continent. The moderating influences of the water bodies here and here kind of cause these lines to be more horizontal. And as we go through, we can see big fluctuations, huge fluctuations. Then it moderates, starts to level out as we get closer to the Gulf of Mexico. Now we look in the summertime. Not much difference. I mean, Texas and North Dakota, not much difference. Whereas up here in the wintertime, huge differences, especially in the springtime. And so once again, this is an area with extreme weather. And so one of the things you're going to find is extreme differences not only in the seasons, but also day to day. And so you might have a particular pattern of air mass, a warm, moist air mass comes up here. And so it might interact with this area and bring very, very warm temperatures. Then the next day, cold air mass might come down here. And the next day, you might have super cold temperatures. And in Indiana, we know that changes in the temperature happens all the time. And so this is very characteristic of the breadbasket. Once again, highly continental, going to have changes in the temperature. Also, conflicting air masses is going to be a recipe for tornadoes, and I'll mention that and discuss that more in depth a little bit later on. Here we can see how the isotherm lines now are bending, they're changing, they're now heading towards the poles. Beforehand, in the wintertime, they're kind of bending towards the equator. This all relates to, once again, continental versus maritime effects. And so we see, once again, now how the changing the pattern as we go to winter, we see a much bigger difference in the temperature pattern, the temperature gradient from north to south. Next up, let's look at precipitation. Here's a nice, easy precipitation map, a different pattern. And so how precipitation, we can see how it changes. And so it's hard to see here, but the red and brown are dry, green, especially dark green, are where we're going to see wetter, more humid climates. And so we're kind of horizontal, we're kind of latitudinal here, but we look at the western part of the breadbasket, the pattern changes. So once again, eastern breadbasket, pattern changes in terms of being latitudinal or more horizontal, where here we see the vertical difference. And so as we go west, we get drier. Where here, as we go north, we get drier. And so that's characteristic in terms of precipitation. Now, one thing about precipitation is it does vary from year to year. But nonetheless, here the precipitation map somewhat relates to or overlaps with the similar pattern we saw here in the precipitation map. So here's average from 1961 and 1990, very similar to what it was in 2016. So blue being more humid and green being less, and so it gets drier and drier and drier as we head west. We can see that very much, that vertical pattern right through here. And so, once again, patterns, it changes from year to year. And so, once again, the Dust Bowl was from a pronounced drought period. Well, sometimes you might have a wet period, sometimes you might have a drought period. And so, areas of brown were areas that might have less precipitation than they would expect. So, you look and zoom in to this particular area of Iowa. Very fascinating. I was actually in Iowa in 2016, in this particular area. I was right here. Man, we got no rain at all when I was living in this particular area. But but just the north, they're getting rain almost every night. And so it's kind of, interesting pattern. This isn't just, a particular, this because there was a big, huge, high pressure in this area. No, just kind of this changes, this, varies from year to year. And so these variances also are very important. Why I'm talking about agriculture so much in this particular chapter, why I'm talking about precipitation, because they all relate to each other. There's so much correlation between rainfall and harvest and good crops and all of that.